My name is William Huang, and I'm from Limerick High School in San Jose, California.
My name is Arjun Padiar, and I'm from Irvington High School in Fremont, California.
My name is Jennifer Song, and I'm from Valley Christian High School in San Jose, California.
We are studying the accretion history of the Milky Way using mock observations of galaxy formation simulations.
In the lambda cold dark matter hierarchical structure formation paradigm, a spiral galaxy's stellar halo is thought to have formed throughout accretion of smaller dwarf galaxies onto the larger galaxy. The amount and morphologies of structural features from remnant stars of accretion events help determine the accretion history of the Milky Way, information which helps constrain models of cosmological evolutions of galaxies.
The first step in determining our observational lines of sight was to identify the lines of sight that we were able to observe. In order to do this, we used the catalog of every field that the Hubble Space Telescope observed within the last 20 years as a part of the Halo 7D survey, and we narrowed it down by limiting their parameters to the circumstances of our observations. After this, we grouped our fields into 30 candidate lines of sight. Out of these 30 potential sight, we manually identified 12 for our fall observations on the Keck telescope, with the help of our mentors and faculty advisor. We picked the lines of sight based on the number of halo stars they contain, their proximity to other celestial objects, their reddening and extinction, and their location during our observations. We are now observing these lines of sight on the Keck telescope in Hawaii.
The second part of our research involves using mock observations to determine how much information can be obtained from the Halo 7D survey. We use Bullock and Johnston simulations in which the stellar halo is built through successive accretions of dwarf galaxies and generate a synthetic survey of the stars and their respective properties through galaxia. As you can see from these two graphs of stellar halos, individual features become hard to discern, especially with just 12 lines of sight. Thus, statistical methods are used to differentiate accretion histories. Comparing the variability of line-of-sight velocity distributions between different accretion history simulations, one finds that early accretion leads to visibly similar velocity distributions across all lines of sight, whereas late accretion results in high variability across lines of sight. We are currently expanding upon our research by determining the role of the mean and standard deviation of variability within characteristics such as distance modulus and chemical composition.
Further work is needed to find the dependence of conclusions one can accurately draw on the specific subsample of stars observed, the location of the Sun within the Milky Way, the number of stars per line of sight, and the number of observed lines of sight. We're currently working on modeling observations in galaxia, which we hope to complete in the spring, and combine our observations with 3 previous extensions to determine what we can achieve with the possibility of a complete Halo 7D dataset.
We'd like to give special thanks to our mentor, Miranda Apfel, our fellow star intern, Paulina Garcia, and our additional mentors, Professor Raja Guhatakurta, Professor Connie Rakosi, and Kevin McKinnon. We also wish to recognize and acknowledge the very significant cultural role and reverence that the summit of Mauna Kea has always had within the indigenous Hawaiian community. We are most fortunate to have the opportunity to work with observations from this mountain.